Everyone. Thank you for joining us today. My name is Natalia Martin, and I'll be your moderator for this webinar. Our topic for today is building a game plan for OT remote access. Our panelist, Andrew Ginter, VP of Industrial Security at Waterfall Security Solutions, and he'll share his insight on why OT remote access is crucial nowadays, and he'll give us specific examples on how to choose the right option depending on the industry, specific challenges, and needs. Couple of notes before we start. This webinar is being recorded, and you will all receive an email with the link to the recording within the coming days. There will be a Q&A session at the end of the webinar. Please submit your questions in the Q&A panel at the bottom of your screen, and you can do it at any time during the session. We'll try to answer all of your questions, but in case we're out of time, we'll make sure to reach out to you individually and answer it via email. Also, one more thing I'd like to mention, if you have any questions regarding our solutions in general and would like to speak to one of our experts, I'm going to share a link in a chat box for your convenience, so you can contact us directly. And with that, Andrew, the mic is yours.
Okay, and thank you, Natalia. Thank you, everyone, for joining us. Natalia said I'm going to be looking at OT remote access. We did a webinar, I don't know, 4 or 5 months ago on sort of the spectrum of OT remote access. What are the different kinds of solutions in the space? How does each of them work? This time around, I'm going to, revisit that, but only for, in a sense, the most popular, the most important parts of the spectrum. And I'm going to, focus on those important parts and try to answer the question, where do we use each of these? And, that question has to do with how secure are each of these elements of the spectrum, with how secure do we need our remote access to be? And that's a function of worst case consequences. It's also a function of credible threats. How reasonable is it to believe that somebody will come after us and cause? What are the worst credible consequences? And I'm going to, visit that question in a half dozen industries. So it's a lot of material to cover. I'm not actually going to cover a whole lot about why we do remote access. I'm guessing we all know why we're doing remote access. Remote access was always a thing. It got worse in COVID, and for a great many of us, it just saves an enormous amount of money and time and effort. Us driving into the site, our vendors flying into the site. So everybody wants remote access. The question is, can we do it safely? Can we do it securely? What does that mean? So those are the questions I'm planning to address here. So let's get started with that. I'm going to hit a bunch of solutions. And for each solution, you're going to see on the bottom of the screen, you're going to see sort of a scorecard. The way that we compare security between different solutions, the way we compare the security of different things is with attacks. We ask, which attacks does this solution defeat with a high degree of confidence? Which attacks is it still vulnerable to? Which attacks does the other one defeat? How do we compare these solutions in terms of the attacks that they defeat with a high degree of confidence? So, the first scenario I'm gonna talk to here is the one that I'm guessing everyone's familiar with. In a sense, it's roll your own. Buy a firewall or two with a built-in VPN server, stand up a Windows jump host, like just a Windows machine or 3 in a DMZ, put the VPN product on a remote laptop, log into the VPN, log into the jump host, configure the firewall between the jump host and the industrial network, the OT network, configure that firewall to allow the jump host to connect to most of, if not all of, the OT servers. This is what everybody does. So we're going to look at security. Let's divert just a moment. Here's the scorecard that I'm using. And there's an infinite number of attacks you can imagine. These are the ones that I suggest are the most revealing in terms of the difference in cybersecurity posture between the remote access solutions we're going to be evaluating. So the attack scenarios or the attack the security characteristics. One is high connectivity. This, in a sense, is the opposite of zero trust. Zero trust says Andrew has access to these three machines, and that's it. That's as far as I trust Andrew. But Fred over there has access to everything. High connectivity says if I get in, I can see pretty much everything. There's no restrictions on every remote access user can touch everything in a sense. So that's a weakness in some of these security solutions. High risk features. If I can do file transfers, I can transfer malware into the OT network, deliberately or accidentally. If I can even do cut and paste operations, I can take a 10,000 line script of malware text and paste it into a text file and run it on the inside. So these features that allow high volume data transfer of potential malware is a security concern. Taking over a firewall, taking over the VPN server and pivoting. Pivoting is where an attacker uses a compromised machine, CPU. It could be a firewall, it could be a Windows box, it could be Linux, it could be a PLC. It's a CPU. Uses a compromised system to attack other systems. In this scenario, the bad guys get into a firewall with stolen credentials, or they get into the VPN with stolen credentials, or they find a vulnerability that has not been patched yet. It's been announced, but nobody's patched it. Or they find a 0-day that hasn't been announced, and they somehow take over the firewall VPN server and pivot through that system into, start using that system to attack OTS. Server pivot is where you have, the firewall. You also have a remote access server of some sort. Instead of attacking the firewall, you come into the remote access server through the firewall. The server says, what's your password? And you find a vulnerability and take it over and pivot into the OT network through the remote access server. A session hijack is where there's a session in progress, two-factor, blah, blah, blah. Everything is legit. Andrew logged in, but somehow somebody gets the credentials and takes the session away from me and logs in sort of in parallel, takes over my session and works their will upon the OT network. That's a session hijacking. A client pivot is where there's malware on my laptop. I mean, we all imagine that secure remote access lets people into the OT network, the people that we want to let into the OT network. 9 times out of 10, though, that's not what secure remote access does. It lets machines into the OT network. And if my machine, my laptop, is compromised, it may be possible to pivot the attack, use the compromised laptop to attack the OT network. And finally, it's not really an attack scenario, but it's a characteristic of remote access. Is it attended or unattended? Attended remote access is where someone on the inside is watching and supervising the remote activity. And unattended is where, we have a substation out in the middle of nowhere. There is nobody there. And I remote into it and work my will upon it. That's unattended remote access. It has less to do with, physical location. It has more to do with, is anybody at the site watching me when I work remotely, or am I allowed to do what I will? In a sense, it's the same as attended versus unattended physical access. If I need to be escorted every second that I'm in a sensitive site because I'm an outsider, I'm a vendor, I'm not trusted, that's attended physical access. Unattended is where I scan my badge and I walk in and there's nobody walking behind me. And I walk anywhere I want in the site, anywhere I can badge into, and I do things without anybody watching. So again, difference between attended and unattended remote access. So coming back to our first scenario, I'm going to go through, I think, 4 or 5 of these scenarios. This is, in a sense, roll your own. You can buy products that are like this, but you can build them yourself. You might have one firewall, you might have 2 firewalls. The one firewall might have 3 ports. one port out to the internet, one port to the OT network, one port to the DMZ, and just have rules saying the internet can connect to the jump host in the DMZ. The DMZ can connect to any of the OT assets. Very very common scenario. How does it compare security-wise? Well, high connectivity is a problem because if my laptop is connected to the VPN, depends on the VPN, but a lot of the VPNs, especially the older style VPNs, connecting to the VPN was the same as plugging into the network. I can send messages to anything on the network. There's no zero trust. I have full connectivity into the network. That's a problem with a lot of these sort of roll your own style. Um, Compromise the firewall, compromise the VPN. I did a paper, this was 10, 12 years ago, 13 ways to break a firewall. The bad news is they all still work. Google it if you're interested. But if you can break into the firewall and ignore the rules because you've taken over the firewall, or add a rule that says allow all, you can attack all of the OT network without even logging into the jump host. High risk features. Most of these, most of these solutions let me, do a file transfer to a file server, just drag and drop. That I'm on the network. That's what the VPN gives me. Most of these solutions let me cut and paste. It's remote desktop going in through the VPN. You can cut and paste through the remote desktop. So again, dangerous features are enabled. The server pivot, if you hit the jump host, that's the server, and the jump host is not fully patched, and you can take over, you can steal credentials, you can get into the jump host. Or you can exploit a vulnerability. You can use the jump host to attack the network. Session hijacking, I gave it a pass. I've been giving this thing more or less a fail on each of these. It does not defeat these attacks with a high degree of confidence. I have been giving the exception to the session hijacking because most of the remote access tools are reasonably difficult to hijack. The thing that is really easy or comparatively easy to hijack is web-based remote access tools. And here we're getting into a jump host with remote desktop or VNC or who knows what. Not getting into it through some kind of web-based user interface. So I've said, it's reasonably difficult to hijack one of those things. If the client pivot, if the laptop is compromised, however, most of the time, these VPNs give me access to OT systems. Malware on the laptop can just reach out and say, oh, look, there's 79 Windows servers that I suddenly have access to through this new network interface, the VPN, and none of them are patched and just goes wild. This is a problem with the classic style of VPN. And the type of remote access, this is unattended. There's nobody sitting on the jump house watching me. I'm doing what I want. So this is, and by the way, I didn't mention it, but imagine that we have two-factor enabled on the jump host. Again, if you're exploiting a vulnerability in the jump host, it's irrelevant. If you're stealing passwords, it is relevant that the two-factor is enabled on the VPN or on the jump host. So this is sort of the roll your own, the most common kind of remote access. And with respect to these attacks, I know it may be secure with respect to other attack scenarios, but with respect to these attack scenarios, it's not that strong. What else do we have? Let's look at the class of, secure remote access. I think of it as software remote access. Not I think of the SRA as software remote access, not secure remote access. Technically, the acronym is secure remote access. I put secure in quotes. Nothing is secure. How can it be secure? You can always imagine an attack that will get through anything. So what does secure mean? So, I put it in quotes. But you can buy these things called OT secure remote access. How do they work? Again, 9 out of 10 of them. I'm doing broad brush here. 9 out of 10 of them run over the cloud. Think Teams. Think Zoom. If you do a Zoom meeting, we're doing Zoom right now. How are you seeing my screen? You connected to the Zoom cloud. I connected to the Zoom cloud, and Zoom connects us, and now you're seeing my screen. That's the way these OT remote access things work. There's some kind of server on the OT network that connects out through multiple layers of firewalls into a cloud service. The remote user, me with my laptop, connect into the cloud service, and we rendezvous. We connect somehow. So how secure are these? Well, again, in terms of high connectivity, that problem does not exist here. A lot of these secure remote access solutions, when you connect, will not just connect you straight into the OT network and work your will upon it. It'll say, Andrew has permission to log into these 3 OT assets. Which one do you want to log into? And you log into those 3 OT assets through the secure remote access server in the OT network. So that high connectivity problem that VPNs give us, that classic VPNs give us, is off the table. That's addressed by this solution. High risk features, yes. These vendors compete based on features. They have a ridiculous number of features, including dangerous file transfers and cut and paste and who knows what else in terms of sending malware wholesale into the target network. Firewall pivot. Yep, there's firewalls in the solution. You breach the firewall, you find a 0-day, you find an unpatched vulnerability of some sort, add a rule and you're through. You can touch any system in the OT network. Server pivot. Well, the server in this case is the cloud. There's a system in the cloud that is exposed to constant attack from the internet. It's a big, complicated system. I'm sorry, it's got vulnerabilities. If the bad guys can steal credentials or break into, exploit a vulnerability in the Zoom cloud, in the Teams cloud, in the OT's secure remote access cloud, the software remote access cloud, you can pivot through the cloud into any of the victim organizations that are constantly connected to the cloud. So yeah, that's a problem. Session hijacking, a lot of these OT secure remote access solutions are web-based. And so yes, steal the cookie. All you need to do is steal the cookies and it's all over. And there's ways to do this. There's vulnerabilities in the web browsers. There's cross-site scripting. So there's ways to do this. This is a concern when you've got web-based remote access. Client pivot, yes. If you've taken over the remote laptop in particular, it's comparatively easy to grab the remote access cookie and use the compromised laptop to send that cookie to the bad guys and they can take over the session. So compromised laptop, the way you pivot through the laptop is web-based session hijacking. And this is, again, unattended remote access. And I had a different attack scenario for the client pivot. In addition to stealing the web stuff, you could have a remote access Trojan on the client that is watching as the client enters their username to the cloud, their password to the cloud, their two-factor dongle secret code, texted to their cell phone. They have all that information. They log in simultaneously with that information, and they distract the user on the remote access host. They put up a window that says, sorry, couldn't get in. Call help. Would you like to try again? Just distract the user for 20 minutes while the bad guys use their stolen credentials through the cloud service. So this is OT, secure remote access. Let's look at something a little bit different that you may not be familiar with. This is something that's used most often with a unidirectional gateway, in addition to a firewall. So what this is, you've got a unidirectional gateway outbound. For anyone not familiar with the gateways, here's how they work. It's a combination of hardware and software. The hardware is physically able to send information in only one direction. There's a photocell on the left side of the device. There is there's a laser a transmitter, fiber optic transmitter on the left side of the device. There's a photocell, a receiver on the right side. You can send from the OT network out to the world. You cannot send anything back. There's physically no laser in the receiving circuit board. So you send information one way and you make copies of servers. You log into a Pi server, an OPC server on the industrial network. You ask it for all of its data or everything new since the last time you logged in. You push that snapshot through and you stand up an OPC server or an enterprise Pi server on the outside network. And anybody now on the outside network who needs the data can ask the outside server for the data, gets the same answer as the inside server would have given, give or take a few hundred milliseconds. So this is the unidirectional gateway, one-way hardware, making copies of servers for easy integration, used widely in many industries. When you have one of those, nothing can get back. This is the point. How do you do remote access? So what a lot of people do is they use a timed switch. So this is the switch on the right side here. You can see timed switch. You stick a key into the switch, you turn the key, and electromagnets connect. And now temporarily you have a bidirectional, 1 gigabit per second connection that can connect a jump host into a firewall, into the OT network. So you have conventional OT remote access, like the roll your own style, or it could even be a software remote access through the cloud. You have some kind of remote access, any kind of software remote access that is enabled temporarily. In an emergency or when you need some help from IT, somebody has to walk over, turn the switch. IT comes in, helps, and then 30, 60, 90 minutes later, the switch automatically pops back, whatever you've got programmed in the device. And now, until someone touches the device again, the OT remote access is disconnected. There is electrically no way to get to it. The only way information can flow is through the one-way out. So this is a timed switch. Let's look at the attack scenarios. Well, it has roughly the same attack scenarios as any other remote access solution. If it was roll your own, or if it's the OT, software remote access that you buy from a vendor, it's the same exposure, but I drew it as yellow here because each of these attacks can only take place in a very small window of time. And so you've reduced the attack surface by reducing the amount of time the attacker has to try and do any of this. They can, touch the firewall, say, oh, it hasn't been patched. Let me, and the switch times out and they can't do nothing. Well, now I have to wait for the next time. Next time someone logs in is 8 days from now. You go, finally, let me in. I'm going to use that vulnerability, and it's gone. The switch has been updated. So it just makes everything harder. And this is attended remote access because someone has to be there to turn the switch. But I flag it as minimally attended because all you have to do is turn the switch. It's not like somebody is sitting there watching you. Someone has to turn the switch and walk away. So it's minimal intervention, and it's all of the exposure of software, but only in extremely, temporary situations. This solution is used most commonly when remote access is rare, is not commonplace. It's something that happens infrequently. Let's call it that, infrequently. Here's something new in the world, hardware enforced remote access. Again, it's used most commonly, but not exclusively, when you've got an outbound gateway and you need remote access to come in. How does it work? The HERA, the hardware enforced remote access solution, is 2 gateways, one out, sending screen images out, one in, sending keystroke and mouse in. And each gateway has 2 CPUs in it. So the HERA solution has 4 CPUs, 2 on the inside, 2 on the outside. Each gateway, the outbound gateway, has 2 CPUs, one that gathers the screen images and sends them out, and the other one gathers keystroke and mouse. So how does this compare to the rest of it? Well, This is something that when you log into it, you are presented saying, Andrew, you're allowed to log into these 3 hosts. So the high connectivity thing of VPNs is not there. This is zero trust. Andrew only has access to those 3 hosts. So fine, that's all I get. High risk features. Hera, at least Waterfall's Hera, um, has been designed from the start not, to reduce the attack surface. Has been designed from the start to reduce the attack surface, not to have these high risk features. You cannot do file transfers through it. You cannot do, high quantity cut and paste. It simply doesn't work. So that's off the table. The firewall, take advantage of a vulnerability in a firewall and pivot doesn't work. Even a 0-day doesn't work because there's no firewalls. The only firewalls on the IT side. You can break into the IT network, but there is no firewall to break into to get into the OT network. Pivot through the server. It turns out that, I won't go into details, but if you compromise the IT facing CPUs in Hera, you still have gained no access to the OT network. It is Hera, the inbound hardware, hardware and software together are combining to eliminate the possibility of internet protocol stuff going through. The standard way to pivot is to use the internet to get into, to use Ethernet, to use internet protocol to get into your first victim. Use that victim to use TCP and IP to get into your next victim, and so on. The Hera solution breaks that pivoting path. You cannot use any kind of standard attack tool to get through the hardware. So it takes that off the table. Session hijacking, there's no web-based user interfaces. All of the credentials are buried in the crypto. It's just really hard to hijack these sessions. Again, designed from the beginning for security. Client pivot, I gave it a yellow. In theory, it is possible to break into the client and wait for everything to log in, and then try and move the mouse and try and start typing on the keyboard while the user isn't looking. In theory, that's possible. In practice, it's hard. The user gets suspicious, turns off the laptop. So it is possible in theory, but it's very difficult to pull off. You cannot just steal the cookie. You cannot just steal the credentials and run it on another machine the way you can with software remote access, because the Hera login session is tied to the hardware. It's tied to the trusted platform module in the hardware. Again, the Hera client this user, Andrew, logging into that system, can only run on this laptop. Even if you steal the 2-factor and other credentials, you cannot use them on another device. You're stuck on this device. So again, not perfect, not check mark with a blue, but much harder to use a client pivot than in conventional remote access. And my last one here, I'm running a little short on time. I can do this. Is what am I doing here? Hardware force remote access. Here we go. Unidirectional remote screen view. This is something that's existed with most of the unidirectional gateway vendors forever. It's one way out, nothing back. What does that mean? Well, you turn on remote screen view on 1 or 2 or 3 assets on the industrial network. You can send those screen images, just like you're seeing my screen image here. You send those screen images through the one-way hardware out to the world, and a vendor, my control system vendor, logs into the little web server that's built into the unidirectional gateway with a VPN and 2-factor, blah, blah, blah. Logs in and can see the screen. But of course, the vendor can bang on their mouse and their keyboard all they like. Nothing gets back through the hardware into the industrial network. The vendor's on the phone. We need an engineer on the industrial network moving the mouse, typing on the keyboard, according to the instructions of the vendor. The engineer is supervising the vendor. The engineer only moves that mouse when they understand why they're moving the mouse and why this is the right thing to do to their equipment. The vendor thinks they're supervising the engineer because they're the ones providing expertise to diagnose and solve a problem. They're cooperating. So this is extremely secure and attended. Okay, it's intrinsically attended. There's no way to do unattended remote screen view. It doesn't help. So these are the options. Here's how they compare. now that we know how they compare, the question is not, let's pick the most secure and be done with it. I mean, some people do that, but most people say, no, no, no. If I want to know how to apply this knowledge of how secure these things are to my needs, I need to do a risk-based analysis. I need to understand what are my worst-case consequences and how does that affect my decision, my choice of a secure remote access platform. I need to understand threats. Is it possible for an attack to cause those consequences? So let's look through, let's start with consequences and then move into credible threats and then pull it all together for a few industries. So um, consequences. Most people imagine that we understand what are the worst case consequences in our systems. People get into the safety instrumented systems, they disable them, things blow up, people die. People, you assume that's the worst. And, you know, there's actually people who assume that isn't possible because they don't realize that safety instrumented systems are software and all software has vulnerabilities. But it is. Most of our safety instrumented systems are connected to the OT networks. All of them are software. And if we can get into the OT network and connect to the safety instrument system and compromise it, in the worst case, if we can then manipulate the physical process to cause an unsafe condition, so the safety instrument system fails to, shut us down when that unsafe condition, now we have, explosions and death. So this is a possibility. The thing most people don't realize is that most of our SIS is connected to the network. Something a lot of people don't realize is possible at all is equipment damage. Misoperate a large turbine and it tears itself to pieces, and now we're down for 9 to 12 months, as long as it takes to produce a new turbine. Burn out a transformer. High capacity transformers are custom built, every one of them. It takes, actually, I read just a week ago, there's a backlog. It takes 2 to 2.5 years to build one of these transformers. People are ordering, they're building a solar farm and they need a transformer for the solar farm. They're ordering, the first thing they do before they turn the ground on the solar farm is order the transformer because the lead time is so long. Protective relays are supposed to protect the transformers, but also software. They're also almost always connected to the control network. If we can compromise the control network, we can connect to the relays and say, change the set points on the relays to say, instead of, tripping to protect the transformer when the input voltage is, higher than 100,000 volts, say trip to protect the transformer when the input voltage is higher than a gazillion volts. And the transformer burns out if we can cause an overvoltage condition in the transformer. Bricked equipment is even simpler. Just erase the firmware, and now the equipment's dead. Erase the firmware so thoroughly that it's not possible to boot the device to the point where you can restore the firmware. If you cannot boot the device far enough to restore the firmware, you're done. It's over. Throw it away. What happens if most of our PLCs in a power plant or a pipeline are bricked? A lot of us have 10, 20, 30% spares because we expect these things to last us 10, 15 years. And we know the vendor isn't going to be selling these things on the end of the 15 years. So we buy enough spares to keep us, to tide us over when sort of natural failure of these devices over time. Don't realize that if someone comes in and bricks 80% of our PLCs, we only have 30% spares. Now what do we do? Long downtime. Cloud pivoting. A lot of people don't really pay attention when you connect to a cloud service of any sort. And the most common cloud service is predictive maintenance. Connect to the manufacturer of our physical equipment. Connect to the control system vendor. Let them, send them information constantly so they can monitor our stuff and tell us how to maintain our stuff optimally, or sometimes come in by remote access and maintain it for us. But if that cloud connection is compromised, if the cloud is compromised, we can pivot through the cloud into hundreds of industrial sites simultaneously. This is a problem. And there's other conditions that you cannot build safety instrumented systems for. The one I'm familiar with is in pipelines, there's the concept of a hydraulic hammer. And this is a high pressure condition that is moving through the pipeline at the speed of sound. A couple of these hydraulic hammers collide and the pipeline ruptures. There is no, you can say we have overpressure relief valves at locations where the hammer tends to happen sort of naturally. But if you bring it about deliberately, we could, in principle, cause the pipeline to rupture anywhere along the pipeline. So there is no safety system for that. It's the way you prevent that is operator process. Anytime we have a process that our operators follow religiously, because to fail to follow it is unsafe. Every one of those processes is something we don't have automation to prevent. That's why we have the process. That's a risk. So these are blind spots. Um, how much trouble are we in? This is from the latest threat report. You can see it, on the Waterfall website. Just go to, waterfall-security.com/2025-threat-report. The threat environment changed half a decade ago. Okay, before that, a lot of threats just weren't credible. They just weren't happening. Nobody believed they were happening. Nobody could see they were happening. Today, a lot of stuff that a decade ago was deemed not a credible threat, those things are happening today. Not just they are credible today, they're happening today. What's credible today is much worse than what's happening today. We're seeing, most of this activity is ransomware. The high end of ransomware is buying and selling, exchanging tools with nation states. Okay, the high end of ransomware has enough money to buy tools from not very friendly nation states, and enough money to build their own tools that are powerful enough that other nation states are buying the ransomware attack tools. Equipment has been bricked. Safety systems have been breached. Nobody's died in heavy industry. I mean, there have been deaths in hospitals. Nobody's died in heavy industry because of a safety system breach, but safety systems have been breached. Equipment has been bricked. Substations and transformers have been targeted with equipment damage attacks. Nation state attacks tripled over last year. Still small numbers. 6 nation states attacks last year, 2 the year before, 1 the year before that. Is this a trend? I don't know. But the difference between ransomware and nation states is that a lot of the time ransomware just sort of accidentally causes plant shutdowns and worse, equipment damage. Nation states deliberately try to bring it about. And they're the ones that design, typically. I mean, there's been some ransomware that's designed control system capable ransomware, but most of the nation states are the ones that designed the control system capable ransomware. There were 3 control system capable ransomwares discovered last year, 2024. That's as many as were discovered in the previous 6 years combined. Again, is that a trend? Is that an anomaly? We don't know, but the threat environment's changing. What is credible has changed dramatically. How do we use that? When we do this risk assessment, when the worst case consequence is acceptable, we can use frequency, we can use severity, we use a traditional attack matrix, a risk matrix, and you can evaluate the security of the remote access against the matrix. Bluntly, if we have only acceptable consequences, we can probably buy insurance to cover that. Which remote access should we use? The one the insurer recommends, because they're the ones who have accepted the risk. Do what the insurer tells us, and they will cover us if we're breached. We're good. When the consequences are unacceptable, in many jurisdictions, it is illegal to deploy anything less than the most secure practical solutions. So what do you do when the consequences are unacceptable? 9 times out of 10, you cannot buy insurance. You have to ask the question, what is the set of attacks we defeat with a high degree of confidence? What's the set of attacks we don't defeat? Because you can always imagine more and more bizarre attacks. There's always attacks you don't defeat. The line between them is called design basis threat. The question that we have to ask is, these are the attacks we defeat with a high degree of confidence. Are there attacks above the line that pose credible threats. Is it reasonable to believe? Credible means, is it reasonable to believe? Is it reasonable to believe that these attacks will cause serious consequences at our site, at a site like ours, in the next 2, 3, 5, 7, whatever our planning horizon years is? If we have credible threats with unacceptable consequences, what are we going to do about them? Ideally, we deploy security strong enough to defeat them reliably. And so this is sort of the context. Again, every organization has different thresholds, these words mean different things to different organizations. But let me give you some examples now. Extreme example, nuclear generation. You know, what is the worst case outcome? It's a catastrophe. It's not a disaster. It's a catastrophe. I define a disaster as, 3 states in the United States. The governors declare states of emergency for hurricane recovery, and people come in and clean up after the hurricane. The lights are out in some places for up to 3 or 4 weeks, in rural areas, for 3 or 4 days in heavily populated areas. That's a disaster. The worst case with a nuke is a catastrophe. Chernobyl went up, and thousands of square kilometers of territory have become uninhabitable for centuries. That's a catastrophe. That's the worst case. If, the worst possible thing, if every control system is deliberately misoperated in the worst possible way, overriding all of the safeties, that's what happened at Chernobyl. With respect to remote access, what's the credible threat? An armed incursion is a credible threat in my mind. If I have remote access into a nuclear generator and a terrorist group wants to make some kind of stupid political statement by causing a catastrophe, they could break into my home, put a gun to my head, put a gun to my kid's head, and say, Andrew, log in now. What am I going to do? When we have a credible threat and a credible consequence that is unacceptable, it does not matter what remote access, how secure remote access is. The gun to the head scenario, if that's a credible threat, we cannot deploy any remote access. I work with some of the world's nuclear plants. None of them have deployed any kind of remote access into their critical networks, into the networks able to bring about an unacceptable consequence. Excuse me. Is this likely to change in the future? I don't think so, because the gun to the head scenario is not going to go away. So nuclear generation does not happen by the risk-based assessment. What's the worst that can happen with a conventional generation? Long-term equipment damage is probably the worst. Again, turbines shake themselves to pieces inside of their metal housing. The metal housing is a lot of metal designed, specifically to protect nearby workers if the turbine shakes itself to pieces. What are credible threats? Well, there have been living off the land techniques launched against, these are remote control attacks that are extremely difficult to detect, launched against electric utilities. That's a credible threat. That threat is out there. What's the credible consequence? Well, here's where experts disagree. Some experts will say, well, they will say all of the threats that can bring about an unacceptable consequence, because they generally see a turbine tearing itself to pieces as unacceptable. All the threats able to bring about an unacceptable compromise can be detected. Okay, only detectable threats are credible. And so you're not going to see a 9-month outage because a turbine shakes itself, but all you'll see is a 2-week unplanned outage, and that's acceptable. We can buy insurance for that. Other experts will say, no, I don't believe that you can detect the living off the land. I do believe they could bring this about. So there's disagreement. Currently, generally speaking, in the largest conventional generators all over the world, you've either got some kind of remote access. Most of them have the sort of roll your own, but they're starting to deploy the cloud-based stuff. They either have that or they have unidirectional remote screen view. Okay, one way out, nothing back. attended remote access. In the future, I'm seeing that many of these sites are considering HERA. They're considering hardware enforced remote access because it's unattended and it's almost as strong as the unidirectional. And the unattended is just so attractive. They're looking at their credible threats and they're saying, the people with software are saying, I'd like to be stronger and moving to HERA. The people with remote screen view might be saying, I'd like to be more convenient. And I think the difference in the risk posture is minimal. And they're moving to HERA. So this seems to be what's happening in conventional generation. Renewable generation. Again, bricked equipment, long-term damage to wind turbines, to battery packs are possible. Credible threats, again, living off the land is a credible threat, extremely capable, extremely difficult to detect. Again, experts disagree as to the credible consequence. Some say, all that you can cause is mess up a bunch of systems, have to shut everything down, clean it out, and you're back in 2 weeks. Others say, no, if you brick the RTUs, if you tear apart the turbines, now we're down for a very long time. Experts disagree. In practice, what is deployed right now, in my experience across pretty much all renewable generation, is software-based remote access. Why? Because they absolutely need the unattended remote access. These systems are much comparatively newer than conventional power generation. They just need more attention from the vendors. And so they're using the software-based remote access because that's the only thing they can use. That's the only thing that can get the vendors in as much as they need to, nearly constantly into one piece of the solution or another. In the future, I'm seeing that many of these are going to migrate to hardware enforced remote access. They're using today's software remote access because it's the only thing that gives you unattended remote access. And as much as they wanted something stronger, it wasn't available. Today it's available. A lot of them are, I'm predicting, will migrate to HERA. Did I miss one here? No, here we go. Refining. Again, worst case is explosions and worker casualties. These things happen. Things blow up at refineries. People die. This is, this is well known. Credible threat, again, living off the land is a credible threat. Compromising safety systems has happened. It is therefore a credible threat. Targeting protective relays has happened in the electric sector, not in refining, but that's an industry close enough that pretty much everybody in refining sees all of these threats as credible threats. These are out in the world and threats that people have to be aware of. What's a credible consequence? Can those threats bring about deaths and explosions at the refinery? This again is where experts disagree. Some will say no, all credible all worst case consequences are detectable, and so they won't occur because we'll catch them in time. Others will say nuts to that. They are, we believe that it's a credible consequence that we need to address with a high degree of confidence. And so some of these refineries are using unidirectional gateways, they're using secure bypass or the temporary switch, or they're using remote screen view. Even the ones that are using software today, a lot of them are going to migrate to HERA. They're going to migrate to the unattended hardware enforced remote access because it just makes sense. When even if you're reasonably confident that you cannot bring about these worst case consequences, there's a nagging doubt. And given that HERA is now available, and this piece of the puzzle was not available 2 years ago, I'm predicting people are going to migrate to this. Pipelines, again, worst case is a hydraulic hammer. The credible threat is the same as refineries. Credible consequence, again, people disagree. Today, most pipelines, most petrochemical pipelines are using software remote access or unidirectional remote screen view. I'm predicting they're going to move to HERA for the same reasons as refining. Manufacturing, the worst case varies enormously. Sometimes it's 2 weeks of downtime. You just cannot imagine a cyber attack bringing about more serious consequences. In other cases, it depends on the physical process. You could have worker casualties, you could have long-term equipment damage. It varies enormously. So you have to look at What is your worst case? The credible threat, well, it's at least remote access, the remote control, the remote access Trojan. Uh, the credible threat is, this is what all ransomware uses. Nation states have been using remote access Trojans to break into manufacturing when the manufacturing is, in a sense, strategic. They want to steal robotics programs from advanced manufacturing in the West to use in factories in China or other places. So nation states have been breaking into OT systems, stealing industrial secrets. These are credible threats. What's the worst case credible consequence? Again, experts disagree. With some factories, even I agree, the worst case is a 2-week outage. With others, experts disagree, but you could have material financial outages. Honda, a few years ago, had 4 of their factories go down for 2 days. They lost 8 days of production. They were producing, I might have it wrong. It might have been 2 factories for 2 days. They lost 4 days of production. They were producing 1,000 vehicles a day. They lost 4,000 vehicles. They run those factories 24/7. On the end of the quarter, they were 4,000 vehicles short of their quotas. This adds up to a $250 million or $500 million, depending on the price of the vehicles. So the consequences, even when safety is dealt with, can be material. Currently, software-based remote access is used pretty much universally in discrete manufacturing, but I'm predicting that we're going to see some of those sites, the most consequential sites, move to a stronger unidirectional security posture with hardware enforced remote access because of the consequence, because these attacks are becoming more credible in their industry. That's what I had for you. I'm guessing most of you have been on waterfall webinars before. We are focused on OT security. We do some work with government agencies as well, but most of what we do is in heavy industry and critical industrial infrastructures. We have offices all over the world. We're deployed all over the world. We're trusted by heavy industry and critical industrial infrastructures all over the world. So that's what I had for you. How do we do this? We compare the security of different tools, different scenarios, different designs by looking at attack scenarios and saying which attacks do these different solutions do or do not defeat with a high degree of confidence. Compare the attack postures. Credible threats keep getting worse. So keep an eye on the threat environment. And the great debate, the big thing experts disagree about is, given the credible threats, what are credible consequences? And more experts are saying, no. These consequences, they're unacceptable and they become increasingly credible. We need to do something. The whole, entire industries are shifting towards more secure postures because they have to, because they're looking at the risk environment. And something new in the world is hardware enforced remote access that fits between software remote access and the long-standing attended unidirectional remote screen view. That's what I had for you. Sorry I had to blast through it so quickly. I always seem to have more to say than I have time. By the way, if you're interested, the latest advice from CISA and a bunch of other agencies in other countries, Google Modern Approaches to Network Access Security from CISA or even from CCCS, the Canadian Center for Cybersecurity, and you'll see the latest advice from many government agencies is, again, rethink your software. They have a lot, they're saying, the old style roll your own is probably not secure enough anymore. They have a lot of discussion of different kinds of cloud style cybersecurity. And they've got a section on there saying, for high consequence, look at hardware enforced. So it's not just me saying this. There's other authorities out there saying this. This is what I had for you. Natalia, do we have questions?
Yes, Andrew, thank you for this great presentation. We've got quite a few questions. I'm not sure we have enough time to answer all of them, but let's try to take at least a few. So the first question is, I would like to combine an SRA solution with Hera. The SRA will help the access, Hera will help with the actual hardware security. Is this possible?
It's absolutely possible. Let me give you an example. One of the things I have not mentioned is a password vault. Um, a password vault is one where that in an OT network or in an IT network for that matter. Let's say we have a lot of machines. Let's just say we got a network of Windows machines. All of them has a local administrator account, and it's typically one account. You generally do not want to create a local administrator for every one of your 7 administrators. And if one of them leaves, you have to go and touch every machine and change out the local administrator accounts. It's just a lot to do. And so what people do instead is they'll deploy a password vault. You take all of the local administrator accounts and put those passwords into the vault. And now if you want access, and the vault goes out and changes the password on those machines. So now if Andrew logs in and says, I logged into the jump host, I logged into Hera, and Hera lets me connect to an engineering workstation. Okay, Hera, connect me to the workstation. From the engineering workstation, I'm sorry, I can remote into any part of the OT. Hera and all of these OT remote access solutions, they give you zero trust for the first step. But if you get into something powerful like an engineering workstation, you can take a second step. Now, you're not supposed to do that. People, usually follow procedure. But if you want to that next level of protection, you use a password vault. So you get into a system with, the cloud-based remote access. It says you're allowed to get into the engineering. Now, from the engineering workstation, I log into the HMI, even though my zero trust OT cloud solution did not let me into the HMI. I can pivot. I can use the engineering workstation, get into the HMI. It doesn't work because I no longer know the password on the HMI machine. The password vault has changed those passwords. If I want to get into that, I have to go to the password vault and say, I'm Andrew, give me the password for that machine. Or change the password, let me log in, and then change it out again so that nobody ever knows all of these admin passwords. And this is a second level of zero trust deeper into the network. So yes, you can absolutely deploy that behind Hera. You can deploy it behind a cloud-based, secure remote access solution. You can deploy it behind your jump host. I don't see a lot of people doing it because it does add complexity, and you have to scratch your head about what do I do in an emergency? What happens if the password vault goes down? I better have, another password vault. It increases the complexity of your solution. So I don't see it done a lot, but it's absolutely possible in theory, yes, depending on the component that you're looking at. And I've done a very high level overview. There's lots of little detailed components that are possible, some of them even OT focused that are possible behind the hardware for solution. Absolutely, yes.
Thank you. The next question, does AI increase consequences?
Does AI increase consequences? I think the answer is yes. It's not. The research that I've seen, it's not that you can go to ChatGPT and say, write me a script that will, brick the RTUs, brick this model of RTU and that model of protected relay. ChatGPT will go, what? Or, worse, we'll give you a whole bunch of code back that does nothing at all. Um, there's tools out there that write code. Not ChatGPT talks to you, but there's tools out there that write code, AI tools. Again, if you go there and say, give me attack code for such and so, they'll say, what? And they'll give you garbage. But if you already know how to write the code yourself, you know how DNP3 works, you know how the protective relays work, you know which register means what. You can use these powerful AI tools to speed up your software development process. So if you already know what you're doing, you can increase your productivity as much as 10 times in terms of producing these attack tools more quickly. So, what that suggests to me is that we saw 3 attack tools last year that were control system capable, we're likely to see many more of those attack tools in the future because writing them has become simpler. Script kiddies off the street cannot do it. But if you're already expert enough to do it, AI will definitely speed you up.
Thank you. Next question. What will be your IDP for Hera?
My IDP, what's an IDP? Doesn't say.
Yeah, no, it doesn't
No
say.
idea. Sorry, I don't know what an IDP is.
Okay, let's take another question.
Yeah.
How can Hera protect our OT environment from intentional damage, given that someone will have remote control over it?
Again, if a disgruntled insider is a credible threat. So let me say first, I've positioned Hera as unattended remote access. In fact, there's a whole bunch of features under the hood of the waterfall Hera. One of the features is attended remote access. So let's say, I've got a vendor who's coming in, and I trust them to operate their equipment by remote control, but I don't trust them that much. I only trust them some. Oh, my laptop is running out of power. That's okay. It'll survive the rest of this session. You can set up Hera to say when Andrew logs in, who I kind of trust, when Andrew logs in, send me a notice, and I will connect to Andrew's session. Andrew can only log in if I give him permission. And when I give him permission, I'll say, show me what he's doing, and I'll watch him. And if I don't like what I'm seeing, I disconnect him. And in fact, the next question Hera asks me is, you just disconnected Andrew. Would you like to disable him permanently? Yeah, he's out, he's done. So you do have the ability to do that. But if you have a completely trusted insider who can get into your engineering workstation and whatnot, that's a problem. This is why we're talking about remote access. How do you manage insiders, malicious insiders is a hard problem. You design your most critical systems so they need two people cooperating to make changes. There are design things you can do to address the insider threat. You have to do all of that. Hera doesn't solve that problem for you. That's a different problem. Some of remote access is relevant to that problem, but a lot of that problem is just the design of your system. Give me a second. I'm going to plug this computer back in. But maybe read the next question.
Sure. So how are Hera manufacturers, support companies considered to be safe from a supply chain compromise attack point of view?
This is a big problem. Again, not unique to remote access. Any system that you buy and deploy into a high consequence OT network, do we trust the vendor? And this is arguably the topic of another whole book. But what the industry urgently needs to invent, because I don't think all the solutions are out there. I mean, there's solutions out there that say, do I trust the company I'm buying from? Are they on a banned list? Okay, make sure that's not the case. Do they have they published a software bill of material so I can tell if any of the software they use has vulnerabilities that they haven't patched yet? Again, that doesn't really solve the problem of, entirely. Do they have a security program, a good security program that hopefully will prevent a nation state or some nasty getting into their system and planting malware when they didn't realize it, and it doesn't show up on their software bill of materials because someone put it in there surreptitiously? Well, that's a harder thing. Can I prevent people tampering with the product while it's in en route to me? Taking it out of the FedEx warehouse and tampering it, and putting it back in. These are all different problems. And to me, one of the most difficult is what if a bad guy gets into one of my vendors and changes their development process? All the others have reasonably straightforward solutions, reasonably high confidence, but preventing a nation state getting into a trusted supplier is a problem. What I believe the industry urgently needs to do is, figure out for each different industry, for each different system, how we can design our systems so that even if they're compromised, ideally we can detect the compromise, but even if they're compromised, is there a way to design the systems in such a way that they cannot cause unacceptable consequences, that they can inflict upon us only acceptable consequences? Part of this is the big cyber-informed engineering initiative. It's one of the reasons I'm a big fan of that initiative. But I think there are design approaches that you can use to answer that question. But I do not see people systematically doing the research to answer that question. So to me, that's an open question that urgently needs further investigation, and probably a whole spectrum of solutions and design alternatives.
Thank you. Well, unfortunately, we are running out of time. Let's take one more question and just wrap it up. Do Hera systems support MFA such as Azure integrated conditional access and allow only one session at a time?
I don't know if Hera supports Azure. You'd have to ask our solution architects. They're the experts on the product. Um, I do know that it supports multi-factor, which one I'm weak on. So if you're interested, reach out to Waterfall and we can get you connected with the experts who can answer that question.
Okay. Well, I think that's it for today. Andrew, do you want to add anything else?
No, just, thank you for everyone joining us. Thank you, Natalia. I will try to get to the questions on the webinar, but I've been on the road a lot and I'm on the road this month. It might be another few weeks before I get around to all of the questions. I haven't finished all the questions from the previous webinar. I'm determined to answer all of those questions, but it might take a little while. I'm traveling, overseas later today and, desperately trying to get ready. So, yes, thank you for the questions. I love the questions. I learn from the questions. Um, and I will get back to you. I just can't promise when, but if something is urgent, again, reach out to Waterfall, reach out to me on LinkedIn, and let's have a conversation rather than in me trying to imagine what the question means and put a general answer together in email. Thank you again.
Thank you. On behalf of Waterfall, we'd like to thank you for joining us today, and we'll see you next time.